of China, who will describe interactions among Arctic atmosphere, sea, ice, and ocean, and their links to the climate in China. Dr. Lei, thank you.
Dear President, ladies and gentlemen, my name is Ruibo Lei. I come from Pro Research Institute of China, also a member of China-Iceland 5 cruise. Today I want to give a talk on the interaction among Arctic atmosphere, sea ice, ocean, and their link to China. In my presentation, there are 5 parts. First, I want to give a brief introduction on the rapid change in Arctic sea ice, and there are links to China. And then I will show some fieldwork on the interaction among atmosphere, sea ice, and ocean during the China-Iceland cruise, and show some results, and give the talk on the discussion on the future work. As our load, during the last 10 years, the sea ice, Arctic sea ice decreased so quickly. In the summer of 2007, it reached to the record minimum, and compared with the climate average, it decreased about 17%. The decreased rate of Arctic sea ice is faster than any result from the IPCC 4 model results. So, for the state of the Q1 and state of Arctic sea ice, there are 2 points of views. One would say is the new normal state. They would say Arctic sea ice will change by year by year, but will not decrease so much from a Q1 state. The other we say is a tipping point. They will say the Arctic sea ice will decrease faster than the Q1 state. And Arctic Ocean will ice fill after several decades. From the data of the submarine uploading sonar and the satellite data, you can find that both in the winter and the autumn, the Arctic sea ice decreased about 1.5 meters. Also from the helicopter measurement, the model sea ice scales decreased also about 1.5 meters. The sea ice dose will survey through the summer, then the first year ice will change to be the second year ice or the mid-year ice. In the recent years, most first year ice could not survey through the summer, so the decreased rate of the mid-year ice is faster than the first year ice. The very old sea ice with age larger than 5 years can only can be found in the North of Canada and the Greenland. Because the reduce of the Arctic sea ice, since 2007 there were five continuous summer, both for the Northeast Passage and the Northwest Passage is completely open. The opening of the Arctic roads will reduce the shipping costs from China to the North American and Europe. For example, from Shanghai, China to the Reykjavik, Iceland, the distance will reduce about 3,100 nautical miles. As our knows, Arctic warming is 2 times as that of the global warming. Due to the warming in the Arctic region, the sea ice will reduce, and more open water and deep will will be occurred. Then the solar radiation will be absorbed by the upper ocean. The heat released to the atmosphere from the ocean to the atmosphere then will make some influence to the atmosphere circulation. For example, in China, the Chinese climate will be influenced by the Arctic change through the atmosphere wave. Just so by the Dr. Yang just allowed that there are very freezing wave happened in the southern China during the 2007 to 2008 winters. The traffic and electrical system has been damaged to a high level. The mathematical modeling shows that this survey phasing wave will be weakened or disappear if there are low unusual sea ice minimum in the 2007. For the first to the third Chinese Arctic cruise, our major measurement region is the Chudi Sea, Baltic Sea, and the Canada Basin. During our cruise, we will set up the CDD station and some short ice station and ice camp will last about 10 days. In the 2010 cruise, because our ship reached to the northmost point of 18.4 degrees, so we can do the investigation in the Central Arctic and deploy the ice balance buoy over there. In the 25 cruise, to visit Iceland and carry out some investigation in the North Atlantic, we also pass through the Northeast Passage. During the navigation, we also can explore the shipping condition over these Arctic waters. Because the Pacific inflow, the warm water will result the large reduced sea ice in the Baltic Sea and the Chudi Sea and the Canada Basin. So our cruise will cover this important region. We also can carry out the ice sample to do the measurement of the forcing of atmosphere and explore the orbital feedback that will lead to the solar radiation and also the influence of the melt point and the lead. We use the helicopter to measure the sea ice concentration, melt point coverage, and the surface albedo. We also do the ship-based measurement both for the sea ice thickness and sea ice concentration. Over the ice station, we set up some equipment to measure the mass balance of the sea ice and the interaction among the atmosphere and sea ice in the upper ocean. It's a CTD data, CTD work and moving buoy, and we also use the ROV to do the measurement under the sea ice. Because of the importance of the Nordic Sea, we also deploy the meteorology and the oceanographer coupled buoy in the Norwegian Sea in this cruise. We also set up the meteorology tower and use the balloon to measurement the atmosphere boundary layers. The surface albedo is depend on the area weight among the sea ice melt point and the open water. Compared with the PLV's measurements, our data show that the surface albedo is smaller than the PLV's result because the increase of melt point and open waters. Over the ice sample, we also can get the sea ice thickness distribution we can get the result just like that. Over the regions, because the large sea ice thickness of about 2 to 2.5 meters, the melt away is relatively smaller. And for the region near the melt pond, because the ice thickness is just about 1.5 meters, so the melt away is small. We also measure the incoming, outgoing radiation over the slow-cover sea ice and downward radiation under the sea ice. For our measurement set, for the sea ice thickness of about 1.5 meters with several centimeters of slope, about 20 to 13% radiation will be absorbed by the slow-cover sea ice, and about 15 to 18% of solar radiation will flat, and about 2 to 7% radiation will be transported through the slow-cover ice layer. This is the ice-balance buoy depot in the China-Iceland 3 in the summer of 2008. This buoy just flew from the Alpha region to the Amazon base. During its growth season, the ice thickness increased from 1.5 meters to 3.1 meters. From mass balance data and the sea ice temperature profile, we can get the conductivity heat flow through the ice cover, and also the oceanic heat under the sea ice. The oceanic heat show large seasonal change from autumn to the spring. It will decrease, and however, over the South region, because the shallow ocean deep over there, so the oceanic heat flux is relatively large. We in the China-Iceland 4 cruise, we also deployed the buoy in the Central Arctic because the large oceanic heat over the through the Flame Strait and the loss of Flame Strait, so the increase in the ice thickness is smaller than the one deployed in the last years. The sea ice speed also increased from the Central Arctic to the Flame Strait. Use the buoy data, and we also update our model, and use the update model. We model the very famous shipper data. The result is good compared with the observed results. During this cruise, we explore the shipping condition through the Northeast Passage. Along this passage, we just can see the heavy sea ice over the Treaty Sea and the Eastern Superior Sea and the Wisconsin Strait. There are a good relation between the sea ice condition and the ship speed. Over the heavy sea ice regions, the ship speed will be smaller than 6 knots. By the August 8, the Northeast Passage is completely open through from the Barents Strait through this passage to Iceland is completely open. Both the Flame Strait and the Northeast Sea are the critical parts for the Arctic Ocean system. So we're looking forward to promote the cooperation with Icelandic scientists to explore their work on the Arctic trade. In the future, maybe we can share the logistical platform, for example, the Icelandic research vessel or the Chinese research vessel and the Yellow River Station in the Svalbard to do some more field work. Thank you for your attention.